Welcome to video clip 6.2, in which we provide an overview of DMN. As we've seen in the previous video lecture, the goal of decision management is to model well-defined operational decisions, thereby improving transparency, maintainability and supporting change, and also the automation of decisions. Decision management answers questions like how is a decision taken, which data is being used, which policies are taken into account, and who is responsible for a decision. In order to support these types of models, the decision model and notation has been introduced as an OMG standard in September 2015. DMN considers two levels of abstraction, as we'll see shortly. Later this year, a new upcoming version, 1.1, will be published, but there are no major changes in the upcoming version, so that everything you learn here for DMN will also be valid for the version 1.1. The top level is the decision requirements level. That is the business level to define the structure of decisions, their inputs, and also relationships between these decisions, and a few other concepts as we learn a bit later. In DMN you can also specify decision logic, which means it defines how decisions are actually taken. You can use decision tables or also business rules to do so. Looking at the relationship to bpmn, you can say that DMN complements bpmn very nicely, but DMN can also be used without bpmn. Okay, so in order to look at the decision requirements diagrams, we return to the example of setting a credit rating, as we discussed in the previous video lecture. So here we have had a process that uses information about the debt of the applicant and the employment history to set a credit rating, either to A or B or C. So looking at this in a bit more detail, we have first the decision about the debt, and when the debt is low and the history is good, I come to credit rating A. When the debt is high and the history is good, I come to B. I also come to B when the debt is low and the history is bad. And finally, if both things are not so good, I'll end up with a credit rating set to C. So we now can think about how can we encode this logic, not in a process, but in some sort of table, in some sort of decision table. And I like to sketch a decision table for the decision logic of this process as follows. So we have certain inputs we see here. And the inputs will be represented in decision requirements diagrams. So we have here two different inputs. First of all, we have the decision, that is the top level here, determining credit rating, and then we have two inputs, the debt and the employment history. And decision requirements allow us to specify exactly what are the decisions and what are the inputs to the decisions. In this case, just the inputs, the debt and the employment history. So let's now look at the logic that I indicated in the previous slide a little bit. So coming up with a table looks like this. So first we have one input, that is the debt. Another input is the employment history. I just write history here. And we can use information about the debt and the history to come up with a credit rating. The credit rating. And I will sketch a table. And let me do so. And now we can try to think about how the input is related to the output. So when the debt is low and the history is good, I come up with credit rating A. So when the debt is low, the history is good, I come up with the A. So this one branch in the process can be represented by this one line in the decision table. If the debt is low and the history is bad, then I come to B. If the debt is low and the history is bad, I come to B. I also come to B if the debt is high and the history is good. So high, good, I also come to B. And finally, I come to C when the debt is high and the history is bad. Then I come to a C. So we see that we can use a table, and this is basically a very simple form of a decision table. But this decision table encodes exactly how the decision is taken, how the input is translated to the output. So in which input combinations I come up with which output. And we have a bit cleaner, version of the decision table here in the lower part of this picture, but it's, let's say, the same table as I discussed before. Now, when we have the decision requirements of this example on the right-hand side, and when we have the decision table that encodes the decision logic, we can also look at how a process would look like that uses this decision. And here we have a new version of the credit rating process, in which we have one decision task, determine credit rating, and that's specified by the decision, determine credit rating, with the same name. And the output of this decision is encoded or is represented by this data object in bpmn, which is called credit rating. And then we have one additional activity called set credit rating that reads the credit rating data object. And when we have the decision logic in this table, we can have exactly the same decision logic that we encoded in the process before that. We have now encoded in the decision table, where we can use the decision logic in this process. And we all see that this process is a lot simpler than the original process that we introduced before. So let's look at the second example, which is from an insurance claim process. We discussed this also before. So the idea here is that we have a client, and the client sends an insurance claim about maybe the theft of a bike. The claim is received, it is registered. Then we have the decision task here, where we decide on the claim coverage. If we decide to compensate the damage, we end up here, so we can prepare a letter of approval. Otherwise, we prepare a letter of rejection, and we'll send either letter of approval or the letter of rejection. And of course, the interesting part here is actually, again, how is this decision taken? First, we want to add data objects, because we have learned already that decisions take data, and also in bpmn we can specify data objects to process models to make them richer. And here we have basically two data objects that we want to take a look at, which is the claim data object, and that's written by the register claim, and that's read by the decision as input. So when we have a decision or when we have an input to a decision, we can model that in bpmn as reading a data object. But another data object is read by the decision, namely the customer contract data object. And the decision is taken based on these two inputs. We can specify this also in the decision requirements diagram. And here we have it in the lower left part. We have the decision requirements diagram, where we have the decision, decide on claim coverage, and we have input values. But we have three inputs here, because we need to be a bit more precise. We are a bit more precise in this decision requirements diagram. Here we have an input called claim.value, and we have claim.theft-time. And these are attributes of the claim data object. So we use here the internal structure of the claim data object that might be represented in a UML class diagram or some other form of data model. And we use this attribute information in the decision requirements diagram to make exactly clear what is the concrete input to the decision. And from the customer contract data object, we use the customer contract type. And hereby, we actually provide a reference between the two models. We look a bit later this week into consistency between process models and decision models. And here we see for the first time that there is a need for taking a look at the decision between these two models. For instance, we have here the customer contract as a data object, and we have here an input that relates to this customer contract. And the same holds for these two inputs to the decision that are also, or that are connected to the claim data object in the process. So looking now at the decision table, we came up with a decision logic for deciding whether the claim should be covered or not. And we have it here in the lower part of this slide. So let's briefly talk about some of the rules that we have here. So we have here the claim value, we have the claim theft type, and we have the type of the customer contract. And these refer to exactly the inputs to the decision in the decision requirements diagram. Here also we can encode the decision logic. So the first rule reads like, if the claim value is up to 200 euros, then I don't care about the theft type and I don't care about the customer contract, and the output is yes. So any damage not exceeding 200 euros will be covered. And then we have some logic introduced. So if it's between 201 and 500 euros, so rule 2 says if it's between 201 and 500 euros, the value of the bike, I don't care about the theft type. If it's a gold customer, I say yes. And I also say yes if it is covered, if the theft type is between 6 and 22 hours and it is a silver customer. And so forth. So you can read through this decision logic and you will find that we will have, let's say, very detailed, very specific expressions that explain very well how this decision is actually taken. This brings us to the end of video clip 6.2, in which we provide an overview of DMN by first looking at decision requirement diagram model, which models the structure of decisions. And we also took a brief look at decision logic that expresses how decisions are actually taken.